Hello everyone. So in this video, we're going to talk about what the Levenshtein distance and edit distance problem. And we're going to create a program. So edit distance is a way of quantifying how different two strings are from one another by counting the minimum number of operations required to transform one string into the other. The Levenshtein distance between two words is the minimum number of single character edits. Example: insertions, deletions, or substitutions required a change one word into the other. So each of these operations has a unit cost. So, for example, the Levenshtein distance between kitten and sitting is a 3 minimal edit script that transforms the former into the latter is like this: kitten, sitting, or substitutions of S for key. And then sitting substitution of I for E. Then setting insertion of G at the end. The added distance problem has optimal substructure. That means the problem can be broken down into smaller, simple subproblems which can be broken down into yet simpler subproblems and so on until finally the solutions become trivial. And then here, problem transform string x1 to n into y1 to n by performing edit operations on string x. Subproblem: transform substring x1 to I into y1 to j by performing edit operations on substring x. So in a case 1, we have reached the end of either substring. So if substring x is empty, insert all remaining characters of substrings y into x. The cost of this operation is equal to the number of characters left in substring y. So in this case, the cost number is 3 because in a first string and second strings are the same. So if substring y is empty, insert all remaining characters of substring x into y. The cost of this operation is equal to the number of characters left in substring x. So as you can see guys, if the string is equal to the characters, the x and y is equal, so the cost of will be going into the same as the character. While in a case 2, the last character of substring x and y are the same. So if the last characters of substring x and substring y matches, nothing needs to be done. Simply recur for the remaining substring. So x 0 to I minus 1 and then the y 0 to j minus 1. As no added operation is involved, the cost will be 0. So as you can see guys, the last character of this x and y are nothing needs to be done. So in ACC and ABC, so the last character is C, so which is equal to AC and AB, so it costs 0. As you can see, it said here that the case 2 is if the last character of substring x and y are the same, so nothing needs to be done. So we can remove this and it costs into 0. In the case 3, the last characters of substring x and y are different. So if the last characters of substring x and y are different, return the minimum of the following operations. So firstly, insert the last character of y into x, and then the size of y reduces by 1 and x remains the same. So this accounts for x1 to I and then the y1 to j minus 1 as we move in on the target substring but not in the source substring. As you can see guys, ABA and ABC become into ABAC and ABC because as you can see guys, it said here insert the last character of y, which is the last character of y is C. So this C is going insert into x, which is ABAC. So here, the ABAC and then the ABC. And the second, delete the last character of x. So the size of x is reduces by 1 and y remains the same. So this accounts for x 1 to I minus 1 and then the y 1 to j. As we move in the other source string but not in the target string. So here, as said here guys, delete the last character of x. So our x here is ABA. So we're gonna remove the A and become into AB, and then the Y remains the same. So our Y are the same characters. Substitute, replace the current character of X by the current character of Y. The size of both X and Y reduced by 1. This accounts for X 1 to I minus 1, then the Y 1 to J minus 1 as we move in a both source and target string. And our example here guys is ABA, which is our X, and ABC is our Y. So as said here, the current character of X will be replacing the character of Y. So as you can see guys, our ABA and ABC become into ABC and ABC because our Y character is ABC. As said here, the current character of Y, it replace or substitute into X. Our X substitute the character of Y. It is basically the same as case 2 where the last two characters match and we move in both the source and the target string. Exhibit cause and edit operation. And now guys, we're gonna create the Levenshtein Distance program. Firstly guys, we're gonna create a string which is S1 and S2. It represents the first string and the second string. So we use scanner here guys because it allows you to read the input of various primitive data types like int, float, or string, or etc. And the next line, we're gonna create an int, which is, it gives our first string and second string a length. So here, n It represents our first string length, followed by the M, which is our second string length. In this line, we're gonna create a 2D array and we name it into distance. So the example of this 2D array is distance A and B is the added distance of the first A letters of S1 and the B letters of S2. So here, this is the matrix initialization. So in this line, if we want to turn any string into an empty string, the fastest way, no doubt, is to just delete every letter individually. So as I said, the fastest way, no doubt, is to just delete every letter individually. So the same principle applies if we have to turn an empty string into a non-empty string. We just add appropriate letters until the strings are equal. So these three variables I made is for storing potential values of current added distance. So we are done for this program. So our first string here is ABC, then the second AB, CD. So we expected here that our distance of S1 and S2 is 1. So here, and then this is another example, which is our first string is Jim. So as you can see here, guys, the distance of S1 and S2 is 2. Now this is the end of my video. I hope you will learn something. God bless. See you.